Hi guys, welcome back to my channel, and this is my sixth lecture on machine learning. In a previous video, we can learn how to build a machine learning model and how to split data into training and testing sets. Yes, but today we can understand why some machine learning models fail even our code is correct. Yes, yes, we can, and today we can learn what is an underfitting, what is an overfitting, and what is a good fit model look like. And finally, we can understand the bias and variance, which are the main reason behind this problem is. And do not worry if you're completely beginner. This video is for beginner friendly. But if you are not seeing my previous video, please go and watch my previous video, then come to watch this video. Yes, in a previous video we can learn what is a test we can in a previous video we can learn how to split testing and training data. Yes, this way. Go and watch that video and then come to watch this video. Yes, let's start. Let's start our today's session. First of all, we can see what is an underfitting. Let's first understand the underfitting. The underfitting happens when the model is too simple to understand the data. In the case, the model performed poorly on a testing data and also poorly performed on testing data. This means the model has no and that means the model has no learned the relationship properly. For example, and underfitting is like a student who study very little and fail both practical test and exam. That's a simple explanation of underfitting, and also we can see the practical implementation of what how underfitting happens. Yes, let's go in our coding section. Let's see how underfitting happens. First of all, we can import the libraries. The first libraries for you we are using pandas is used to handle and store data in a table format. And second data is linear regression. This linear regression is the machine learning algorithm that we can use for today for this problem. Yes. And third library is training and testing split. It used to divide data into training and testing part. Yes, that's in a simple libraries. And first and we can run this cell. It's okay. This cell is running correctly, and we can go in a further cell. In the cell we can create a data set. Yes, see here we can creating a data set. In that data set, the hour in hours is the input feature. That's our first column, and our second column is mark. That's an output that we want to predict. Yes, let's execute that. And in that data set, there are not having relationship between hours and mark. Let's see here. For 1 hour study, the student got 55 mark. For 3 hour study, the student got a 70 mark. For 8 hour study, the student got 40 marks. That's not a proper relationship between hours and marks. This why the underfitting is happen. Yes, this why the underfitting is happen. Let's execute this cell. Let's go in a further cell. We can create in a further cell. We can convert that data into a data frame. And data frame is required because the ML model works better with structured data. Is As we can see here, our data is having in structure format. Means in a row and column format, and also indexing. Yes. Let's execute this cell. Yes, it's okay. It's executed properly, and further say we can split the input and output data. Yes. First of all, X contains the input feature like an hour means hour, and Y contains the target value means marks. Yes. The ML model learns the relationship between X and Y. Yes, let's execute this cell also, and also we want to see what inside the X. Then also we can also see the in X we can see here the our column means input section. And also we can see in Y, see here the 5520, that's an marks. Yes, that's in a simple. If you are, but if you are not seeing my previous video, first of all, go and watch that video and then come to watch this video, because in my previous video I can explain that how to split the training and testing data. That's the most important part. Yes. In this cell, in the further cell, we can split the data set. We can split the data set into training and testing purpose. Yes. Let's see in this cell what happened. The X train, Y test, Y train, Y test, and also we can split that using a trace training testing split. Yes. Yes, and also we can assign the testing size is 0.2. That means the 20% of data is used for a testing purpose and remaining 80% used for a training purpose. Yes, that's I think you can understand that. Uh, and we can go and we can run this cell, and further we can check the training data size. Yes, yes, we can check the training data size. In this line, the number of training samples. So since the data is small, the training data is contain a few rows. Yes. First of all, we can run this cell. We can see X train contain the six rows. Yes. Our total data is 8. For training purpose, we can use a 6, and for testing purpose, we can use 2. Means 80-20 for 10, 80-20% ratio. Means our splitting is correctly happening. Yes. Let's go in a further. We can create the model here. Then we can create the model. This lines create a linear regression model. The model is not training yet. This just empty object. This line is just empty object. We can train the data here. For here we can use a training using we can use the train data using a training data. The model learns in this the model learns relationship between hours of studies and marks. Yes, let's execute this say. Yes, let's our model is uh, creating our model is creating. And for further check, this is the most important part for today's lecture. We are checking the model performance here. Yes, here. First of all, we can check for a testing. We can check for a training. How model is how model is performed. First of all, score is calculate the R2 score. Yes, yes. The score means this calculate the R2 score. First of all, the training score, the training score tells how well the model learns the training data. Yes, yes. See here, the training data model learns 0.04 0.0145. Yes, that's an too low. That's an very low performance. And also we can see here, and also we can see for a testing, and that's also the very poor. That's an also very poor performance. Yes, then means here happen the underfitting. This model perform the underfitting. Let's go on our definition. Now you can clearly understand what is underfitting. Yes, underfitting happen when the model is too simple to understand the data. In this case, the model perform poorly in training data, and the model also perform poorly on a testing data. See here in a real example. Yes, training data also perform very poor. Yes, see here in a training 0. Okay, wait a minute. Okay. This happen very poor. Yes, training data is also performing a model very poor, and testing also very poor. This happens under fitting situation. I think you can understand what is an underfitting with a real world example, and also some theoretical knowledge also. What is an underfitting? And let's move further. What is an overfitting? Now, let's understand the overfitting. Overfitting happens when the model learns the training data too perfectly. Means overfitting happens because the training data models learns perfectly, too perfectly. In the case, the model perform extremely well on a training data. Yes, but performing very poorly on testing data. This means the model has memorized the training data instead of learning the general pattern. Yes. For example, overfitting is like a student who memorized the answer but fail when new question is the question is changed. When the question is changed. Yes. Also, we can see this overfitting in practical implementation also in a coding way. First of all, we can simply import our library, but instead of we can use here decision tree. Then you are saying what is a decision tree? Yes, in a further lecture we can see the proper what is a decision tree, what is a regression, what is a random forest. There are further models we can see in a further videos in a further way. But today today we can see the big picture of that. What is the decision tree? Yes, let's only see. For we can use a decision tree, a decision tree regressor. First of all, we can execute this cell, and also we can change some data also. For our section, we can use 1 2 3 4 5 and marks 20 90 24 88 85. This also not showing the relationship between the hours and marks correctly, but let's see what happen. Let execute first cell, and also we can convert that into the data frame as, and also we can split the x and also we can split the x and y. And for building a model we can use a decision tree. Let's see, our model is building correctly. Wait, now our model is trained correctly, and let's see how it's work. Let's see. Now our training data is 100% performance well, but in a testing data is very low. That's happen here. That means the overfitting is happen here. Let's go in our definition. Now you can understand the very better what is an overfitting. Overfitting happens when the model learn training data too perfectly. In our model also the training data is understanding the very well, means perfectly. But in a testing data, they are performing a very low. Yes, this is an overfitting situation. Yes, I think I think you are underst I think this also you can understand that. Then we can go in a further. What is a good fitting model? Means how to overcome that underfitting and overfitting. Yes, let's see what is a good fit. Now let look a good fit model. A good model perform well on training data and also well perform in a testing data. This means the model has learned the real pattern and can generalize the new data. Yes, in our for example we can see in a real for in a practical way we can and here we can use a linear regression here, but the code is same, but we can change the data set here. We can use 1 to 87, and but in mark we can use 20 25 30 35 40 45 50 60. Yes, see in this data set the relationship between mark and hours is very good. First of all, 1 hour study, the student got a 60 or 20 mark, sorry. 2 hour study, the student got a 25 mark. For 8 hour study, the student got 60. This is the best relationship between hour and mark. Yes. This data goes into the good fit. Yes, let's execute the cell first. That we can convert into a data frame. You can split here training, input and output section. We can split here training and testing data. We can create a model. We can build a model of linear regression here. Yes, we can execute this cell. Yes, our model is creating perfectly, and we can see the performance of our model. See here, our training data is 100% and testing data is also good, 0.9, 0.94. That means, and our good fit definition, what we say, what it tells, what we say, what uh, and our good fit model definition says the correctly. A good model perform well on training data and perform well on testing data. This means the model has learned the real pattern and can generalize the new data. In our example, we got training score closely to 1, yes, and testing score also high. This is exactly what we want in a machine learning. A good fit model works well in a real life scenario, not just knowing the data. Yes, that's an all explanation of what is an underfitting, what is an overfitting, what is an good fit. Yes, I think you are understand, you can understood that what is an underfitting, what is an overfitting, and what is a good fit. Yes, and we can take some summary of that. We can also comparison. Underfitting means bad on training data and also bad on testing data. And what is the overfitting means very good on training data but bad on testing data. And good fit means good on both training and testing data. And the goal of machine learning is always a good fit. Yes. Then see here, I can show you some diagram also here. See here, this diagram is for underfitting, this diagram is for a good fit, and this diagram is for overfit. See here, in this diagram we can see the values or time. We can see here this line is for a best fit line. From best fit line, this dot is very far. See here, this dot is very far and they are not seeing the relationship between values or time. Yes, this is known as a underfitting. And overfitting means, let's see here. This is an best fit line. This they are showing the dots, but they are actually aligned on the best fit. That means that this is an O. This align this dots are aligned on the top of the best fit line. This means this model is overfitted. Yes. Yes, and the good fit means this here. This is an best fit line. This dot is means by this dot means by a best fit line, and this black dot is representing the our training datas. This shows they are very close to the best fit line. This is a good fit or robust model. Yes, that that's a simple uh, di diagram of underfitting, good fitting, and overfitting. Yes, but 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 the main question is why this happen? Then why this underfitting and good fitting happens? Yes, they are having a concept like a bias and variance. In this video, we can see only the simple explanation. In a further video, we can go in a depth. What is a bias and variance? It is not a it is not from it is not a difficult, but let's see what is a bias. Simple explanation. Bias means how much the model oversimplified the problem. Means high bias model is too simple. The important pattern are ignores. Yes, that leads the underfitting. Yes. Yes, the bias means how much the model oversimplified the problem. Means high bias is model is too simple. and ignoring the important patterns from that data set. This leads to the underfitting. You can think like a bias as the model is making too many assumptions. Let we can see in a underfitting that we are seeing in a underfitting. Yes, and variance. Variance means how much the model depend on the training data. Yes, high variance is high variance means model is too complex. It learns the noisy and small details. That leads to the overfitting. It's you can think of variance as the model changed too much with the data. Yes, and also we can see this also see in our overfitting section also. Data are depend on a training data. Yes, that learns the small noisy and small detail also. That learns the noisy and small detail also. This leads the overfitting. Yes, that's okay. I think you can understand what is an bias and variance. Yes, okay. So today we can learn what is an underfitting, what is an overfitting, what is a good fit model look likes, and how bias and variance are reason behind this problem. Yes, but we can not seeing the bias and variance in a depth, but in a further video we can see what is a bias and variance in a depth. Yes, yes. In the next video we can go depth into the how we can reduce the bias and how to control the variance. Yes, in a depth and how to build a better model. Yes, if you are if you are learning machine learning from the scratch, subscribe the channel and like the channel for more beginner friendly machine learning videos. Let's see in a further video. Bye.